You're listening to a Pop House Network podcast for developers by developers. Welcome to Java Pop House episode 92. Hey everyone, this is our 92nd episode. My name is Freddie Guime. I'm one of the principal engineers at Expedia, Java champion, speaker, author, and I'm here with my partner in crime, Bob.
Hi everybody, Bob Paulin, independent consultant from Chicago, Apache Software Foundation member, Java champion, CJUG board chair, and speaker.
Yeah, and today is going to be a very, very fun episode. First of all, if you don't know this, that we are actually recording this as video podcast now as well. So you can, if you've always been dying to look at the code that we write or that we're going through, now it's a perfect time to do it. Like, just go into our javapophouse.com, and when you click on the RSS feed, you see that there's two of them, one for audio only and then the other one with video. Or if you want, you can just subscribe to our YouTube channel too. So so you can see as we go through. But the interesting part is that today we're going to cover essentially different types of serialization, and there is a long history on serialization that happened with Java. And it has a lot of consideration. Sometimes we tend to forget and we just tend to go with it, but it's going to be a very super fun episode. But before I dive in, I wanted to thank our sponsors. Today's show is sponsored by Datadog, a monitoring and analytics platform that integrates with over 400 technologies, including AWS services, Docker, and Kubernetes. Datadog's platforms brings together metrics, traces, and logs in one place, so you can get full visibility into your environment and improve your application performance. With machine learning-based alerts, customizable dashboards, and distributed tracing, Datadog makes it easy to unify disparate data sources so you can troubleshoot faster. Start your free trial today. Listeners of this podcast will receive a free t-shirt once you install the agent and create one dashboard. Visit javapophouse.com/Datadog to get started. Again, that URL is javapophouse.com/Datadog to actually get started. And we thank them for being sponsors of the show to make sure that the mics are on and we keep recording and bringing you great audio and video content. So, with that, let's dive in.
Yes, and I mean, I almost feel like this is an episode, I have it labeled Java serialization, but this is like Java serialization without using the language. I mean, we had Stuart Marks on the show, and I can't remember if Stuart was the one. It's like, yeah, Java has serialization. Don't use it.
Yeah, no. And even Brian Getz, no, what was it? Either Josh Blog? No, I think it was Brian Getz. So that may have been a mistake. Like, and it's interesting. So let's start. Let's describe a little bit of that before we dive into it. And the story is that Java serialization was essentially, I think, Josh Blog described it as a feature that tries to be a framework. And essentially it tried to do many things and not enough at the same time. So what happened was that a lot of the Java serialization woes happened because it's there's a lot of ways that you can actually quote unquote hack it, or there's essentially a vector for security vulnerabilities. Because it sort of like breaks the contract a little bit, where for example, when you think about like the main example is about constructors, right? Like in Java, by the language definition, you're guaranteed that when you create a new class, you will have to call a constructor, and a constructor code will execute.
Except if you're using serialization.
Yes. So, and that was the interesting part, right? Like it broke such a fundamental contract because it was trying to do certain things that were like they were trying to be efficient, right? Like saying like, look, these are the bits in memory, and then we're just going to reconstruct them. But then there were a lot of like caveats about like, how do you serialize this part? How do you deserialize this part? And then there's the whole, essentially, Waterloo on serial version UID and how pervasive that gets when you try to if you happen to declare something serializable, in one of your models, then you see that this becomes very pervasive because it's going to force you to declare everything that is under that particular class as serializable. And then you get classes that you don't even realize they don't have to be serializable are serializable. Like half a swing is like that, which is weird.
Yeah. And they took on serialization very early in the library, in the language, language history. And, because of that, they made a lot of guesses. And with Java, keeping backwards compatibility, they kept a lot of this stuff around, even though, they learned it's like, ooh, maybe we're doing this wrong. But, fortunately, one of the strengths of Java is just the library ecosystem. So what ended up happening is due to some of these problems and even just due to how Java was being used on the web, how it was being used to, optimize performance, and how people formed different opinions on how to properly transfer objects between systems. All of these libraries popped up to kind of fill the issues that people had with Java serialization. I mean, one of them was Java started being used on the web quite a bit, and the web started becoming very much into XML and JSON. Where it was like, hey, we don't need binary data right now. We need stuff that's consumable for the web. So libraries were built in order to help facilitate the data being sent back and forth on the web, usually in JavaScript and JSON. And then, machine to machine, when XML was all the rage, that formats were built around that. So the library ecosystem has done a pretty good job of filling the void where the language was making things difficult or insecure. And that's really what we're talking about today. We're really talking about how do you do serialization without doing it with the language.
Correct. Like we're already hearing that, look, Java serialization, the native one, the one that you declare serializable and you use ObjectOutputStream, which we actually have an episode. It's like, 92 episodes ago or something like that. But it was good and great, or at least it served its purpose. But even the authors of the language are like, you know what? There's other solutions. Do something different. Don't use object serialization if you can avoid it. Yep. And that was it. And it was interesting because you're right. There's two things that I want to highlight. The first one is the Java ecosystem, like you said, is great. It was interesting. I was sitting in a conversation today, and we're talking about JaxB because we do have areas that are like they're still using JaxB a lot. Yeah. And there was a question about they were asking me do you know any C++ XML libraries that we can consume? And I was like, trying to blank, for C++, right? It turned out that there may be some, but they're either proprietary or they're private, or you have to pay a license for. But it's just the nature of there is not a centralized repository where you can download these things or search for these things. It was amazing where thinking about how easy it is for me to find XML processor, JSON processor, or any kind of processor in the Java language. It's because it's just really a Google search away and a Maven dependency include.
Yeah, and some of the serialization libraries that we're going to talk about today actually even have multi-language support.
Yeah.
So I mean, if you are writing your contracts, they have independent ways to represent data structures, and then it will basically compile things so that whether you're writing in Java, you're writing in Go, you're writing in Node.js, you have a client and a server that you can, build around some of these protocols. Yes. So inter process communication and inter system and inter language communication is all possible. Yeah. But we're going to be focusing mostly on the Java bits.
Yep. And the second part that I was going to highlight, which is always funny, and I stole this from Gil Tene, which I think he stole it from somebody else. But he did say there was a period in time where a lot of our networking layer was really just plain bits, right? Like binary protocols. then as you said, like we won't move to the web, and there was this need to like try to do the packet load, try to figure out what's being sent, and Gil was saying, the internet runs in debug mode. Which is true. Like you can actually plug in a debugger, a Wireshark, and see what is being transmitted.
Human readable is a big deal, right? So the human beings are the ones that debug the web. So it did that. That is a great way to look at it.
so and the thing, and it was fun because like a lot of these protocols were meant for that. Like JaxB and Json especially, they're very user friendly in terms of you can inspect them and things like that.
Right.
But there is and again, as I being the performance, not the only performance nut, but it's something that is close to my heart, right? There is an obvious sort of like trade-off on when you're doing text type of payloads, and it was interesting because in our experience, and we'll talk this a little bit later, one of the projects that we're doing is we're trying to figure out how we can optimize a large payload, an XML payload, and just transforming it from XML to a binary protocol like protobufs. We essentially reduce the payload size by an order of magnitude, which in turn essentially reduce the CPU processing time by an order of magnitude. So in a lot of the cases, if your payloads are small, if your stuff is running the way it's supposed to, and you don't have any like performance concerns, and you're not spinning up thousands and thousands of servers, then having the textual data or textual representation of the data when JSON JaxB works well. But if you're having a performance bottleneck and you're wondering what's going on and you still haven't put a finger to it, textual protocols do take a big toll, especially the bigger your payload. And especially also like
recursive payloads where you have nesting and all sorts of things. You don't even realize how much ceremony goes around
reflection and a lot of reflection for JaxB, right? Like it's trying to be smart about it, but it's still reflection, which we know that it's not a cheap operation, at least not as cheap as just spinning up a new object, right?
Yep.
So that is our sort of like game plan. We're going to start circa, I think, 1995.
Back in the day.
Back in the day, right? And it's interesting because like for all the heat that JaxB does get, one of the things is if you follow Bruno Borges, he is the biggest proponent for XML and XSDs. Like and then the reasons why he likes it is one of the things that XML does bring to the table in terms of all these things is that it's very strict. The grammar is very well defined. They try to give nothing to chance, and you have ways to validate that your XML is conformant. You have ways to ensure that your XML has been taken from the right XSD families. All these other things that like they tried to do that in JSON retroactively, but nobody really adopted it as much, just because it's like almost like after the fact. And then JSON, then they became YAML. YAML became like something that then what was the next one after YAML? Gosh, I forgot.
You're getting into places we don't want to go right now, Freddie. It just keeps on going. But the XML protocol has stood the test of time. I mean, it is a very solid protocol, and depending on what you're doing, if you're looking for that strong contract with data validation built in,
it might not be a bad protocol.
It is not a bad protocol for machine to machine where you actually want strictness built into the contract and verifiability.
So let me start with that, and maybe what I should do is,
all right, should I give you screen? Yep, I will give you control of the screen.
All right, share screen, and then we're gonna share this one, and let's start. All right. So So let's start with what XML and what the, if you never heard about it, it's it is at around, I guess, 2001. So yeah, 2000 protocol. And what it is is if you ever seen HTML, it's essentially almost like the quote unquote superset of that. It has almost the same principles with the tagging, where you say, I have like an element, with a begin tag and an end tag. And before we dive in, let's go over the example that we're all going to be working on, which is we created this sort of like internal model that we call it like, it's an order, right? An order here, it has an order ID, it has a customer and a list of items. Something that you have done throughout, all the different experience that we have. If you notice, I have the add data and add builder annotations for my public class order, which are essentially Lombok annotations. So I don't have to worry about getters and setters, and makes essentially my code a little bit more succinct. I'll keep this until we get to Java 14, so we can get the records.
And you have your records, yes.
Yeah. So essentially, the Lombok add data, and I don't think
so Freddie's got getters and setters. He's not being a bad person and breaking encapsulation like it looks like. That's what he's trying to say.
Yeah. So customers, a customer class is public class customer. It has a string name, string address, and a string phone. Something super simple. And the last one that I was going to go to is the item, which is just it has an int item ID and a string name and a big decimal price. So this is essentially the data that we have in our model. And we want to essentially, for whatever reason, right, we are doing microservices. We want to ship sort of like this order through the wire. And that means that we need to serialize it. Now, when it comes to XML, everything starts by the XML schema definition, the XSD file. And what the XSD file is trying to do is telling you what kind of an XML is quote unquote valid, right? So the way it starts is like essentially said, it's going to tell you this is XML, version 1.0, and it's going to tell you that, and essentially, and then it's kind of recursive in a way that the way that the XSD is formatted is as an XML. so there's like tags for everything that I am about to say, right? So there's a schema tag, there's an element tag that says, ooh, customer type. And I decided to essentially post-pend all my entities with types, so we know that these were generated by the XML, by the XML or by JaxB. So what I do is like when I declare an element tag of name customer type, I said that this particular type is a complex type. So I surrounded it by complex type tags. And then I said what this complex type contains. Complex types are essentially composites, meaning like that you expect this to have not just one thing, but like multiple things. And in this particular case, a customer has a name, an address, and a phone. So I declare these as elements and say that the element type is a string. So the way I do that is I just say, open bracket, element, and then I say the attribute name equals, the name that I want, in this case name, and then I say type equals XS string, which is essentially a JaxB supported type. So I keep doing that with name, address, and phone, close my complex type, close my element, and that is essentially one thing now that I can use refer to from other elements, right? So I go with the item type, which is exactly the same thing. Create a new element of name item type. I said that it's a complex type because it contains multiple things. Item ID, name and price go in as item ID goes as an integer, name and price goes as a string. And it's interesting because price, let's put it this way, a lot of money has been spent on how to represent price. And I think we can have like, there's people that make their careers on how to represent price in this. In this particular case, this is just a small example. We're representing it as a string because we, there are many reasons, but like right now it's like, don't think that a double or a float is the best way to represent the price.
Yeah, but it is interesting because you're your Java class has it represented as a big int, and here you have it as a string. We'll see something similar to this in thrift as well, where you have kind of a definition language around it. But I mean, the one thing I guess what you get with this is that item ID is an integer. Yep. So, you know, this is something we can validate against the type as the XML comes over the wire and before we even serialize it. Correct. Or deserialize it, I should say.
Yes. So a lot of the people that use XML documents will have this XSD document as part of it, right? Like the last one, the last element I'm going to create is order type. And here is a complex type that actually has a reference to customer type and item type that I defined before. And the interesting part here is that for the item type, I said that it can occur between 1 to 99 times. So if there's an order that comes with 100 or 1,000 items, that's going to be rejected by the XML. And it's interesting because this used to be a way to create a distributed denial of service attack. Because what happens is if you don't put an upper bound on your element, on your repeating elements, people can actually send like 100,000 elements of item type, overwhelming your server and making it crash.
Keep dump, yeah, out of memory.
So the interesting part is that everybody that has this sort of like XSD definition, JaxB can actually go in and generate the classes for you. And let me.
Yep, and that's why it was interesting. You started with the Java types, and again, that's our audience is going to be much more familiar with that. But it is a very common practice to actually not write the Java by hand, to actually use the XSD to generate the objects, which is, I'm guessing, where you're going with this.
Yes. So it was interesting because what the very first I wanted to show is sort of like how the internal model is supposed to look like. But you're correct. Most people would not start using those objects and then trying to make them XML. They'll start with an XSD contract that they already have, or that they imported, or that they craft first.
All right. And you'll pass these around, between your projects, or they'll exist on the network, and at build time, you can use those.
Correct. A lot of the way that this is done is by saying, like, look, there's an XSD on the shared drive or on this particular website. We're going to use that XSD as the quote unquote template for our communication back and forth, right? So the thing is, I'm a Gradle guy. So I'm going to show you a little bit of like how my Gradle looks. Like the great thing about these particular protocols is all of them support modern build tool chains. So in this particular case, what we're going to do is we're going to essentially say that, we have a Gradle project. I'm gonna use what we call the JaxB plugin to actually say, look, there is an XSD out there. Please get it and create me essentially corresponding Java classes. So the way that we do that is maybe the easiest way to do it is first show the magic and then do the setup.
Yep.
Right. So so here it is. All right. So here is all right. So let's do. So one of the things we're going to do is, here's my project, here's my Gradle W, and I'm going to do clean and...
Hey, Freddie, I'm actually still seeing your IDE and not your command prompt if you're looking to show that.
Ooh, that's interesting.
You may have just shared the one application instead of your screen. So
new share, let's see, screen one. Let's try that.
Perfect. Yep, we're all good.
Right. All right. So one of the things that let me just do this tasks, and then my Gradle, with the plugins that I have, it has a new tasks that is called XJC. And then if I do this XJC, what it's going to do is it's going to go in and actually, let me make it so that like I do a clean XJC. So you can see that there's no tricks in there. And what it's doing is essentially it will start reading my data model XSD file, which is the one that I was sharing over here. Oh, sorry. Sharing over here on not on resources. Sorry. This one here.
Oh, just above. Yep.
Yeah. And then what it's going to do is essentially is going to go in and in main generate resources, it's going to create this comp Java Pop House episode 92 JaxB order type, item type, and customer type with an object factory, which in this particular case, we don't need it, but essentially it is what it is. It is a natural factory if you want to create
it's a
customer type. Yeah. Yeah. So, and if you see like how the order type looks like, what it did is like it added these annotations here, XML root element, XML type, and these are essentially hints for JaxB to say like, look, if you create an order type and you want to serialize it, I know how to do it. This is essentially a root element. This is like a complex element of this type. It's actually required. Item type is required, and sort of like that. And if I'm going to collapse this, and if you see what it generated sort of like a get customer, like the order has get customer, get items, the get item type returns the list of items. And I can actually keep going over it. Like item type is the same thing where there is a sort of like where it came from, what is the actual definition it is. And same deal. If I close this up, then you can see like there was the item ID, name, price, and my getters and setter. All this was generated for me by JaxB and the plugin. So the advantage that I have is that then I don't have to like write any XML code. And if I happen to use these classes, the instances of these classes, then I can actually ask JaxB to generate this for me. So the very first thing is, let's see how the code generation happened, right? Like the magic that Gradle did for us. The very first part is that, we included as part of the build script dependencies, we included the Gradle JaxB plugin. This is a comp GitHub Jacobono, which is the very well-known JaxB plugin. And then after including this, then what we do in our Gradle definition is essentially say two things. There's two parts to this. The first one is there is a new sort of like source set, which is called JaxB. And in JaxB, we actually said that we need certain dependencies. So this goes back to a little bit of the 2001 sort of like JSR standards, right? Mm-hmm. So one of the things that happens is that JaxB is an actually, let me see what JSR is. That I think is...
It's a pretty early one.
Yeah, 222. Yeah, it's 222. So the way that JSRs work is essentially you create a JSR, and there's a reference implementation of it. And then on the reference implementation, there could be, so JSR can have many implementations, including the reference implementations. Now, one thing that happened, and this was a big pain going from 8 to 9, it was that a lot of JaxB was considered a JSR 222 was built in as part of the language, and this was something that at the time it sort of makes sense, but as things went on, the essentially the powers that be and the JCP decided, you know what, JaxB really is a library that can be included. We don't need to actually make it part of the language. And one of the things that happened was that this used to be on the JavaX space, or JavaX namespace. And the thing that they decided on Java 9 is that, look, we're removing this from the core Java libraries. We're going to put them in as a Maven, like as a library that people can download and add to the project, but it won't be part of the regular JDK distribution. So the very first thing that broke, and this is also like if you haven't migrated to 11 yet, which I highly consider.
Which is when it's removed. I mean, there's deprecation and then they're removed.
Yeah. Actually, I think it happened because of Jigsaw. So I think even on 9, you would run into this problem. So if you move to 11, the first thing, if things are not working, is that you need to add the dependencies for JaxB. And that's sort of like what we're doing here a little bit. So the very first part is defining dependencies for how to generate the code. And this part here is essentially this 6 JaxB dependency. One of them is the JaxB XML bind, which is essentially the API. We also have the XJC, which is the command line tool that actually generates the actual classes, the Java code, and the runtime, which it contains some of this stuff like how to actually use or process the annotations. So those 3 are essentially the bare bone minimum that you need to have to actually run this plugin. The other 3 dependencies are essentially done to do fun things about it. Like if you are really starting a project and you are really using XML, I will highly recommend that you use this extra 3 dependencies. And these dependencies are essentially just JaxB 2 comments, which add things to the actual generated code. And what things are we talking about? We're things that now makes perfect sense and they're included by default in most other code generations, but like an equals a hash code method, toString method, inheritance, the ability to actually do inheritance on these classes. So these at the time were considered extra additions that didn't need to be part of the regular JaxB package. So what they did is that they say, okay, fine, we're going to add them as extensions, and that's how they call it, JaxB extensions. But these are going to be, if you want to use them, you have to include them specifically in your project. So that's what these essentially 6 dependencies are. The first 3 are essentially the API of JSR 222. The other 2 are essentially the implementation, and we are getting the implementation from Glassfish. If you don't know what Glassfish was, that was essentially the reference implementation of, I guess, how do you call it?
Java EE, yeah.
Yeah, before it was Jakarta EE, right? So Glassfish was a reference implementation. Restorama worked on this, and essentially it's sort of like the one that people use. There are other implementations. I think Eclipse actually has one, and you can do. And there are a couple that are a little bit of a variant. I think there's a couple of ones that trade one thing for the other. But if you're just doing regular generation, the reference implementation works perfectly fine. So that's the first part, right? We're going to skip over this a little bit. I will talk to this a bit about later. But then what we do is we have a JaxB essentially code block that we got defined. And what we say is like very easy on the JaxB code block, we have to define where is our XSDs at, source main resources schemas. That's where I decided to put it. And then the XJC is essentially the actual command line tool that generates these things. So what the Greater plugin is doing behind the scenes is essentially downloading the command line tool and essentially running it like as if we were doing a java-jar xjc.jar and passing in some stuff in there. It just makes it super, super convenient because now you just define it in the build Gradle. But if you ever want to like debug these things, you just have to remember that. If you can actually run it as a XJC command for the command line, then that is something that you can actually do through the build Gradle process. So XJC has some helper, some like easy to define variables like generate package. So which package class I want this to, or package name I want my generated classes to have. This two here, task class name is important because what this is essentially saying, look, when you generate this XML to Java code, I don't want you to use the plain vanilla standard XJC task creator. I want you to use a special one that actually allows me to add essentially plugins. And then this is what this args and afterwards says. You essentially define an array of args that says, like, for example, X inheritance, because I want to be able to have the inheritance. X annotate, because I want to have extra annotations in the JaxB. The ones that I like is equals hash code and toString. So essentially, because I said to XJC that first, I don't want you to use your plain vanilla JaxB generator. I want you to use the JaxB 2 commons XJC to task, then I can actually add as part of the arguments for that particular task, this particular flags, inheritance annotate equals hash code to string. And then this will essentially inform the code generation that I want those things in there. Last but not least, I just say, where do I want, all the stuff that you're producing, where is the destination directory that I want? And, I specify that, and really that's it. So then what this does is essentially...
Yeah, and if you've ever integrated to like a SOAP service or anything like that, this is kind of a subset of what gets called when you have like a WSDL and you're generating a client to that WSDL or a server interface to it. So this is just dealing with the transfer objects. So it's not generating any sort of a web service interface, a contract, as if you were using a full SOAP service and a WSDL. This just deals with the objects.
Yes, correct. So this here, when I run XJC, what the thing that it's doing is just creating essentially all these generated sources, customer type, order type. Now let's go take a look at how can we use them and use them just in plain Java, not necessarily as part of a REST service or a REST service endpoint. To note, if you're using something like Spring, even when you're using like Apache Camel, because this is such an old protocol, there are there's usually built-in support, meaning like instead of you having to set up what we're doing right now, actually I think that you still need to generate the Java objects. But for example, for getting the REST to read XML and produce you your JaxB object or your JaxB generated object, a lot of these things will just have essentially flags that you just set and say, hey, I want to accept X application XML on this particular endpoint. And they were like, oh, okay, we presume that you're going to be using JaxB, and we presume that the object that you want is a JaxB object, so we know how to handle it. A lot of these, like, again, like Camel, like Spring, will have essentially XML/JaxB flags that you can just configure. So let's just go to see how this looks like, right? So the first thing is for example, here I'm going to create customer, and I said I put in type at the end. The only reason I did it is not necessarily because I don't want to call it customer. I just wanted to make sure that distinguishes from the internal model to the actual, this is JaxB generated code versus protobuf generated code. That's it. But you can name this however you want, right? Customer type is customer type equals new customer type. And you can see that it created the setters for me, so I can set name, set address, set phone. Item type, I decided to buy a yo-yo. Then I create one, and then I have my setters. And then same with the order type, right? I create a new order type. And in the order type, I have set customer type to set the customer that I created before. And the order type, I can get the item type, which is going to be a list of items. And I can say add, one more item. Now, once I have that in there, because this is essentially a JaxB annotated class, like we saw here, like, it has XML root element and it has an XML type of the things that it has. I can actually then just tell it, I want you to create from this particular object that I created. This is a regular run-of-the-mill Java object. I want you to create me the XML. So the way I do that is that there is essentially a static method, JaxB.Marshal, which is kind of nice. Before you have to create the marshallers like per class instance, but this is almost like a helper method that just does it for you now. So you use the JaxB.Marshal, you pass in the object that you want to essentially marshal into string, and that is a very XML. Actually, Microsoft, and I think it might have been even like before that, those words, marshalling and unmarshaling. Yep. And if you never heard this, that what they are is marshalling means that you are transforming from something to a string or a byte, or
byte array. You're
array.
Getting ready to send it over a network or something that maybe doesn't understand object-oriented code.
Yeah, and the reverse operation on Marshall is taking it from a byte string or a byte array or a string, and then essentially convert it back to an object. So if you ever hear somebody talking about, oh, I need to marshal this and unmarshal that, that's what they're talking about. It's essentially converting from an object to a string or byte array, and unmarshaling converting from byte array string back to an object. So we can essentially, we're marshaling it to the string writer, which is just a way to collect an actual string, and then we just going to print it out. As a fun part, I'm just going to print out also the size of the string. So if I decided to run this, we go in to run, and then here we go. It produces a well-formed XML document that has been validated against that XSD contract that we have, right? So it creates an order type, a customer type, puts it on my info, item type, item ID 1, special yo-yo, and price 2234, and it closes out. This is essentially well-formed XML. It's 351 bytes. That number comes in later, but that's really like what it does, right? And then on the unmarshaling, we actually do the same thing, where essentially in this particular case, I'm creating a string with the XML string of something that I want to unmarshal. And then essentially what I do is the same helper function, JaxB.unmarshal. I essentially create now a string reader, which is, same as the string writer. String reader just reads from a string.
Yeah, you want to read from a stream when you're reading these. You don't want to just say, hey, here's a string, because then it'll all be in memory.
That's very important. Right? So yeah. What Bob is, so this is the naive way of doing these things. Is that you, for example, have a REST endpoint and somebody submits an XML to you. A lot of the times that we think of doing is like we essentially get the body of the of the request, and then essentially call toString into it. Yep. Now, what happens there is interesting, because we are forcing the essentially the particular Java application to say, oh, you want me to read the whole thing first, to then be able to continue processing the response. So one of the things that happens is that because you're doing a .toString, you're not dealing with a string. You need to load the whole XML or the whole payload in memory, and then after it's all in memory, then essentially occupying hopefully kilobytes, but there's payloads that are megabytes.
Yep, can be a lot bigger. And a string is, unmodifiable. It's a final thing. So anytime you're modifying it, you're creating a new object.
Creating a new one. Yep. So then what happens is that especially on big payloads, it becomes essentially a big garbage collection nightmare. Essentially forcing the garbage collection to collect more because it's like, this is too big to be on young generation. We need to move it to 10-year generation and all these other things. So that's why, if you notice, almost all, if not all, of the particular REST endpoint implementations for the bodies of messages have two things. They have the body itself and the toString or byte array, but they also have something like a input stream or like a body input stream, something that actually says, it's like, look, I'm not going to send you the whole thing. I'm going to send you bits and pieces. So for JaxB does not need the whole payload at one time. JaxB can actually start working with a little bit of it at a time. So your program becomes super more efficient when instead of just reading the whole body payload, you read just using an input stream, and you let JaxB read at its leisure. So JaxB says, oh, I need 100 more characters right now because I can process 100 more characters. Reads that and then figures out, okay, that means I need to create this object. And then I need to read 100 more characters. But the thing that happens with the previous 100 characters that were read is that went into young generation, and they're almost ready for garbage collection. Nothing happened. No one is the wiser. You didn't require a lot of memory to actually read a multi-gig payload, because you're always just eating it in bite-sized chunks. So that is essentially, don't do what I did here.
Well, I mean, this is just a test, but yeah, something coming over the network is going to be read from a network interface, and it's going to be pulled in as the application is ready.
Yeah, and then if you have a stream, it's way better than trying to do something like this where you have the whole payload ready for you in a string or something like that. So in this particular case, I'm doing JaxB.onMarshal, saying a new string reader for my XML, and then I said what class I wanted to unmarshal into. I'm expecting an order type, so I unmarshal on that, and then when I run this, then I just printed out the actual object itself as it came through. And you can see that it essentially is telling me, like, you have seen this before. This is essentially the toString of the object with the address, but it actually tells you a little bit of the innards of it in a non-XML way, but more of a very succinct key value pairs in the toString.
Yeah.
And the reason why I can do that is because remember when I said on the build.creator, and I go there for a minute, and I said that I want you to, as part of the JaxB generation, I want you to generate me a toString. Then if you look at the actual like order type, it will have a toString method generated for me that contains essentially, like it has a stream buffer and it has the append, essentially tries to do all this sort of like JaxB things to create me a string. Same with the equals and hash codes where these implementations are sort of you expect it to be like, oh, it's a deep equals, trying to figure out like, the equals throughout like different objects that there are. So that is sort of like how you actually can both marshal and unmarshal JaxB content. The great thing about one of the positive things about XML is it's very strict contract. Like for example, if I try to like do something like item ID 1A, because there's somebody who always wants to say like, it's not really item 1, it's item 1A. This in theory should, okay, no, that didn't work.
Just wanted to prove you wrong.
Yeah, no, I think item ID.
Sure, is the item ID the one, or is it?
Well, maybe the price is.
Price is a string. That's
that's right. Maybe I didn't know that. I am confused on this.
Well, there may be. So there are certain things in here where, so it didn't parse it, but there are options you can set where it will error if it can't parse. So yes. I do believe there are ways to set it where it actually does schema validation first, but for performance reasons, I think a lot of those are disabled by default because there is a cost to validating the payload against the XSD.
Yes. So yes. So and I think what we're gonna do is like gonna add to the show notes. How do you actually turn it on for it to be? Because what it did right now is assume that it cannot be validated. Like it validated it just didn't reject it, and it said like, oh, okay, if I cannot assign it, then it's just going to be null.
And most of these have different settings that you can have to tell it how to deal with. Well, what if I don't specify a field? Does it disappear, or do I actually send it back null in the payload? So it's good to call out, what the defaults are, because they all have different defaults, all for different reasons. So
yes,
as we go through this, we'll try to point out places where those defaults come into play.
Yeah.
But yeah, if anyone that's ever written their own parser, trying to go through all this can definitely appreciate the power of just a JaxB unmarshal. Yes. And I'm back writing Java code again, instead of trying to figure out where to terminate and what field am I on. If you've ever done a fixed length pipe delimited type parse into an object, this is beautiful.
No, it is. And so, and again, like you have people like Bruno Borges who will take this 100 times over JSON, and there are reasons. Like it is really a more strict definition of schemas and all that. But with that, let's talk about a little bit of like the reasons why you might not want to use that today, right? Like the first one is that while it's great for certain things, it is not a one-to-one translation to a Java object. So they are things that JaxB is very hard to map into. Especially if you have complex SSDs that contain, so for example, one of the problems that you have is like sometimes the same JaxB definition or like schema definition or like subset is defined in different places. And because JaxB does not force you to have like the common JaxB, the generation suddenly happens to create different package names for essentially the same object. And there's no way for you to tell JaxB not to do that. It will always look at, oh, it's a different XSD, different package name. That means that it's a different object. Even though when you look at the definition and all that, it's really the same thing. So we've been bitten by that. It also have no opinion about dates, and that's a big thing. There's this standard ISO 8801 that JaxB sort of adopts, but everybody has an opinion on what it should represent in terms of the data object. So one of the things that happens is that you have to tell it. You have to sort of like tell it, I want you to generate my dates as this. I want you to map this kind of fields like that. But sometimes two people in two different systems might map the same date field differently. So then what happens is that if you're trying to sort of share code, then suddenly you are into this position where, because you didn't agree on it before, you cannot have code that runs on your particular project run on the other particular project, even though both of you are based off the same XSD. So these are sort of like the things that are like because JaxB is such a malleable conversion part, like it has ability, and we haven't got into details about bindings.xjb, but that is essentially where you're telling it, I want to configure my thing to do exactly these things. We did do a little bit of that by saying I want to actually generate equals hash code and to string, but that is something that I am doing on my code when I'm generating this stuff on my end, which is something that somebody else decided to do something completely different. And that can cause problems, especially if you don't share.
And sometimes, teams will create shared libraries off of these in order to not have that problem. So you do actually only generate the code once. You still can have problems if you go cross language, the generation could be slightly different. If I'm trying to generate something, using something in C that, really you're not using JaxB, right? It's a Java standard. But SOAP, for example, is interop. And, knowing which JaxB settings and defaults are in play can impact your SOAP compatibility, even though the contracts are equivalent, the behaviors may not be supported. But a lot of things you've mentioned are issues in any serialization system. I think the one other thing that I would add to yours is the one that everybody calls out, so maybe it's just too obvious, is it's very verbose compared to some of the other formats. The flexibility of it is very much directly tied to the fact that it explicitly tells you everything that's going on in the data structure in the payload. Whereas other things will make assumptions and kind of guesses and not give you all of that context, which often makes them lighter.
Yeah, no, and that's true. Like the other thing is like when this was conceived, it was conceived in a time before a lot of the performance optimizations and tricks that we learn are in place. So there's still some reflection going on the marshaling and unmarshaling, and it's not as performant to deserialize and serialize. Actually, I think like on some of the there's performance benchmarks. I think protobuf, cryo, and JaxB, and JaxB is like dead last, but like by orders of magnitude last.
Yeah.
Compared to the other ones. So if performance is a concern, I'll definitely, think twice before choosing.
This is a data integrity play. So if data integrity is your very, very top thing, XML is an excellent choice for that. Yep.
So I think that's all the spiel I have for JaxB. I think the only last thing I was going to add is because I did skip on it, but on the build a Gradle, for JaxB, you do need to add some runtime libraries. And this is essentially, again, Glassfish implementation for JaxB runtime and the JaxB2 commons, because we ask it to generate equals and hash code for us. And what these are essentially the definitions of both the XML accessory types, so all the annotations that are there, plus when we look at equals, we saw that it's actually using an equal strategy, and essentially what these are essentially implementations of JaxB2 commons utilities that helps to implement equals and hash code. So, so you need to add these two as part of your payload. And that's what a lot of people get confused. It's like, why do I have to include this like 5 times? And you know, again, these on the top, these 6 are required to generate the code, because it needs to know how to generate it and what are you going to use to generate it. But these 2 implementations here, you use them because the generated code make calls to utility functions and annotations in here, and that's it. So as long as you understand that, then it makes much more sense what it's trying to do, and you live a happy life. So that's all what I have for JaxB.
All right, so let's move on. So let's advance a couple years. So we started, about 5 years to about 2000. And let's talk about when Java started getting more involved in web development and web services. Because that's when Json started coming into play, when folks started integrating not just machine to machine, where you see a lot of JaxB with SOAP implementations, but also directly integrating into the browser using Ajax and service calls that would directly serve a client that was in a web browser. So now I've moved over to Eclipse, so we're no longer in IntelliJ land. So sorry, some people be sad about that. We've also moved over to Maven from Gradle. So if you like your Maven builds, I'm going to talk about how some of these work in Maven land. So the one thing that will stay the same, though, is our data model. So our customer, our order, and our item type are all the same in these. And, we can do a little comparison with length. So I don't have that in my code, but it's an easy enough thing to add. So we can kind of take a look at what these payloads look like. So I'm going to be talking about Json. And Json is an open source project, another Java library that is specifically built around JSON. At least the original project. They do have XML bindings as well. If you want to do XML with Json, there are Json bindings for XML, but they're much more well known in the JSON space, because of the popularity of the format with web integration, and because they are very, very performant. There are a lot of options out there for libraries that can do marshaling and unmarshaling to a JSON format. There's Json. There's, there's just so many, I don't even know which ones to mention.
Yeah, no, that's true. The one thing I will add, just some coloring, right? Json is, like you said, a JSON parser. But what JSON is what is called the JavaScript object notation.
Yes.
And what this is essentially a very JavaScript driven implementation, like representation. Like if you go to a web browser and you manage to get into the JavaScript console, this, like what Bob is showing, is how it will represent an object. It's really picked up exactly as is from the JavaScript sort of like domain, where he tries to define things. So those essentially like almost a key value pairs.
Correct. And it's native to the browser. So JavaScript is the language, the only language, scripting language that runs natively on the browser. So JSON is the format that if you're writing in JavaScript and you get an object in this format over the network, it will automatically handle the marshaling and unmarshaling for you. There's no libraries. It's JavaScript, the language, will take care of this for you.
I think you can actually copy and paste this as a variable definition in JavaScript
absolutely.
code.
You absolutely can. So, I mean, it is just, you can paste it right in JavaScript code and you have an object. This is how JavaScript represents its objects in its language. So again, that really is what drove, the popularity of JSON-based formats away from XML. XML is not the, I mean, you can do XML parsing in JavaScript as well. But with this being just kind of the native way that JavaScript uses it, you can use a dot notation. So, one different way I can look at this object is if, let's say I named this object order. If I wanted to reference different things in it, I could do order line or order ID. And this in JavaScript would give me the value of the order ID field from that object. So, I mean, you can do that type of notation. That does not work out of the box with XML if you're in JavaScript, unless you have parsed the XML into an object. So a lot of it is just about what you get for free with using JSON. So what you can see is very much like XML. It is a very human readable format. The obvious things that are missing is you don't have like the tagging where you have a begin and an end tag. Really, you have more of like a colon notation where it's key value pairs. So you'll have the key name defined, you'll have the colon, which is the kind of the delimiter between the key and the value. And then you may have a string, which would be a double quote representation for start, and then an end double quote to end it, and then a comma to separate that field from another. You could also have an object, which is going to be represented by a curly brace. So here where we have a customer, colon, and then a curly brace, we see we have that customer object, which has its own fields, which, Freddie was showing as a complex type, where that had its own fields associated with it. And then you get in, and now it's strings separated by colons, separated by their values. You also can have primitives like numbers. In this case, if I have an item ID, which is an integer, there's no quotations around it. You just have the number. And then a comma after the number. We can take the quotations out of it, and then JavaScript, in its infinite wisdom, will create a number out of that instead of a string.
What is it? We don't know.
What is it? We don't know. Well, JavaScript has an interesting way of turning anything into a string or interpreting it to be whatever you want.
Yes.
Watch the Watt talk if you're looking for how JavaScript parses things. But again, like very human readable, very simplistic, and very, very popular for the web based on its native use. So let's talk a little bit about Jaxon. So Jaxon has been around for a very long time. It is an open source, liberally licensed library. It is, I believe it's Apache licensed. Let's see, do I have that here? No, this is actually this is the project home. So let's go to faster. So Jaxon Core is the actual core library. Here's our license, good old Apache license. So free to use. I don't have to worry about, there's no spec or anything associated with Jaxon necessarily. It does support several other of the JSON kind of specifications, but it itself is not based on any sort of JCP-based specification. This library grew kind of outside of the Oracle realm of things on its own, and is not actually in like an Apache Software Foundation or anything else. So it's a little bit unique in that sense, but it's been a very successful and very well-maintained project to the point that it's really, I would say it's the de facto standard for JSON parsing and marshaling and unmarshaling. So let's talk about it. So Jaxon. So in my example, just to kind of lay it out, I'm not using any of the ceremony languages that Freddie was using with Lombok. So you can see I have all my getters and setters written out in their full glory. I have not done any sort of toString or any extras. So this is kind of your old school Java implementation. Hojos. So we're going to be just using this. And these I wrote by hand. I didn't generate any of these from code, although there are tools out there that you will sometimes use JavaScript to generate object models from. That is a thing that folks do. I'm not going to be covering that as much because I think Freddie beat it to death. So here, within the Jaxon realm, usually what I end up starting with, and you'll see this in several frameworks, is this object mapper. So the object mapper class is the class responsible for taking objects to JSON from an object, and then from a binary value or a stream and putting them into an object, which could be off the network or could be off a file. I have a few things here commented out. I'm going to get back to that later, but the main thing about the object mapper is this can be configured with several features. You know, Freddie was showing JaxB having different features that he could turn on and off to change the behavior of how the parsing worked, whether there's validation or not. I can do similar things like that with the object mapper, and I'll probably show a few of those as I get to them. So just like in Freddie's code, I'm defining an object. So here I have my customer. I have an order, which I'm attaching my customer, and I'm attaching some items to my order. I'm going to add some beer to my cart.
Yes.
And I'm going to use the object mapper to take that order object and just write it off to a string. And then I will print that string. So I should be able to take this object and put it into a JSON format. Now you'll notice, different than the JaxB implementation, my object model doesn't have any annotations to really instruct it or give it any sort of hints on the fields. Now I can do things like that with JaxB. JaxB actually has a number of different support annotations to do different things with your data model, but I don't have to use them. So what I'm going to be showing is just sort of the basics, and because I think we could do an entire show on JaxB annotations, yes, the different things that I can do by augmenting the POJOs. So I'm printing the string, and then I'm doing it the other way. So I basically saved an order object to the file, and a file in the object mapper is going to read from the file and then give me an order object, and then we're going to print the order ID from that. So let's show the magic, and then we'll walk through what exactly is happening here. So I'm going to run Jackson main, and what we see in our output stream is a JSON object in a string format that represents what we were looking at. So I get basically my marshaled object, which I could then again send over the network to a browser near you to use. And then my file object here is sent into, so if I change this, let's say I change the order ID to 12345A, I can rerun this again, and it's going to print, you know, basically what was in the file. So you can see I'm not cheating. These are different order IDs coming from these different locations. So that's kind of your basic Jackson implementation. Now, things people do in Jackson that drive, I don't know, me a little bit crazy is you can see the power of this object mapper, right? So this object mapper can really do it all when it comes to dealing with the JSON objects. What I see in a lot of code, and you'll see in this class, I have my own object mapper and I'm instantiating an object mapper, is you'll see people instantiate object mapper all over the place. When the reality is you only really need one object mapper in your code to do your mapping. You configure it once and you can share that thing and you can run it all over the place. It's probably one of the most frequent kind of just wasted objects that are created in projects, and then people end up configuring them and they can get out of sync. Having a global object mapper that's configured to how you want JSON to be handled in your application is one of the biggest tools you can add to a project to keep your sanity on how your JSON is being serialized back and forth. So let's look at some of this. So Freddie showed in his project what happened when he changed his order ID, which or his item ID, which was an integer, to a different value. One of the things I've run into with JSON is, or Jackson, is let's say I forget to include a field. You know, before I had everything populated. So let's say I forget to set the order ID. What's going to happen when I run this? So when I run it, I get my order, and my order ID is here, and it's printing null. So if you ever have JavaScript developers on your team that you want to drive absolutely insane, this is a great approach to drive them insane, is to actually send a null back on a field that's not populated. In most cases, you don't actually want to send a field that doesn't have a value. You can configure it, and that is what Jackson's default is to send the null on a field that does not have a value. But what if we don't want to actually do that? Well, the object mapper can be configured with different rules. So we can do, let's see, it's set serialization inclusion, or no, it's actually not a serialization inclusion. It's actually the serialization removal. Let me look this up. That's our ignore nulls. So I always forget the name of this. So here's again, you can see that there's annotations that do this, but you can also set it globally. Set serialization inclusion, include non-null. This is what I want. So nod to Baldadung to having all of the all of the things that I can use here. So now if I set the inclusion, serialization inclusion, non-null, what's going to happen here? I'm going to run this, and rather than the order ID appearing null, it just goes away. So my JavaScript developers are once again happy that I'm not sending these null fields over. My payload also gets a little bit smaller because of this. In fact, let's take a look at that. So Freddie, yours was around 351, I think it was.
Yeah. It was 250.
Let's print that out. So here's my order string. You just did the length, right?
Yep.
I can just print this bad boy out, and then we'll have some idea of, well, what's the actual payload savings on JSON?
Yeah,
mine is 351. So 140. I think, mine may have been a little bit shorter than yours on text, but I mean, you can see like that's fairly significant.
It's like less than
almost half.
Yeah,
we cut it in half by not, more than half. We cut more than half off the object payload by removing all of those end tags that are there in the XML. So again, another reason for JSON's popularity is it is a more concise format, but it does also have problems with it. One of the things that JSON struggles with is recursion within the objects. It doesn't handle that quite as well as XML, where I can have a strict definition. JSON has problems with references sometimes between fields in the objects. If you have things pointing all over the place, JSON doesn't handle that very well. It also, doesn't give you all of the validation rules that you have in XML, where you can make it a lot stronger. Now, some people argue that that's actually an advantage because people working in web development sometimes don't want as strict of a definition. They want to be able to have the loosey-goosey, hey, I'm going to add a field. I don't want all of the ceremony involved in defining a very strict structure. I should be able to put it however I want. Order doesn't matter in JSON, although that's often the same with XML. If I switch,
I think in XML, well, you can tell JaxB how important it is for you.
True. Okay. Yeah. But if I start moving these fields around, it's not going to matter.
It's not
going to move order ID down under customer, it doesn't make a difference to the parsing. So as with Jackson, there's also some interesting things that come up, and Freddie, you had mentioned dates as well. With the new Java 8 dates, there's another set of options that can get enabled. So I'm going to comment this guy. I'm going to move the serialization out. And let's actually look and see what happens. What if I added a date, for example, a new date time to my my order? So if I go into order, let's do private We'll do local, date time. We'll just call timestamp.
Mm-hmm.
We'll get a getter. We'll get a setter. And then let's add it to our order. So I'll just do order, set, timestamp, and then we'll do local, date time. We'll just do whatever it is now, right? That's simple enough. Now let's run it. Let's see what ends up printing. This is why dates are hard. You can see here, this is a representation of the date I get if I do nothing. Whew. Very, very verbose. But there are ways to deal with it. And some of those ways are adding some of these modules to the object mapper that are specifically meant to deal with Java time in JDK 8. So if I run it with these modules enabled, we can see we can have some influence over what happens with the date time. So now you see I have a little bit more concise timestamp.
Yeah.
But now I have basically the same data model, but different payload. So if I'm not using all of these modules on the other side, guess
you
what?
got the same problem.
I'm going to have a problem parsing it. So time is hard, no matter what you're trying to use. And this is just, how Jackson is meant to deal with it. And there are other options. I can set on the object mapper. Let's say I wanted a human readable date. I can set that up to make it so it's a parsable date. I'm not going to show that right now. But yeah, time is hard no matter what you're using. So that's all I had. Freddie, what's Jackson's super popular. I think you use it as well. With a lot of the applications you work on. Is there anything you want to add?
Yeah, no, I think that the biggest thing is understanding, like, I think you're hit the nail on the head. Like, the object mapper is supposed to be only one. And that way you can essentially set it up for all your application. And the reason you want that is because of these things, like how do you handle dates? How do you encode, how do you interpret, because you can do local date, you can do some date time, you can do timestamps, all these other things, right? I think the concern with these two, sort of like with the XML and JSON, is that there is no agreement on evolution. One of the things, and I think the protocols that we're going to go next are sort of like are trying to address a problem. But if you happen to rename a field, if you happen to add a new field, I think adding a new field might be okay. But if you rename things, if you change types, all that stuff, there is very little things to prevent you from doing that. On the XML side, if you happen to get a new XSD schema, then you can try to generate a new set of Java objects that you can use. But on the JSON side, if you happen to change an object and somebody else doesn't have the same deal, that doesn't have that same version of the library, same schema of that object, then things break. Yeah,
and that's actually a good call out. So if I were to add another field, so order ship.
True, false.
So true. So I have a Boolean here where I've added a field. Now what's going to happen with Jackson? Well, Jackson out of the box has a configuration where if you add a field, it's going to break. Again, you can disable this. So if you want to, you can, here, let me comment out all of this and get back. There are ways to say, well, ignore non-defined fields, and then it kind of does what I was doing by default. Right. So I think it's a serialization inclusion rule. So include non-empty. Or not, what is it? Non-absent? I think that's the one. No. I always forget what this one is.
Ignore field.
It's ignore, right?
It's something like that, yeah.
Maybe it's not a serialization inclusion because it's actually deserialization, right? Where is deserialization? Because I thought there was a deserialization.
Yeah, it's configure deserialization feature. Yeah. It's
disable. Yeah, so maybe it's disable. Deserialization feature. Yes. Yeah, so you're right. So we can do deserialization feature and then fail on unknown. Yeah, I think unknown. It's unknown properties.
Yeah.
There we go. So now if I run my object mapper with this,
then it should be fine.
I no longer get an error. It just doesn't, but it won't parse it. You'll see that
because it doesn't know. Yep.
It doesn't know what the hell to do with it. There's nothing in the class hierarchy to parse it. So it just ignores it and still works. So fun stuff.
Yeah, no, definitely. So and that is one of the things, like these two protocols, great for visualizing what's going on. They all have their particular strengths, especially in readability. In some of it, like molding, like you can actually just open a text editor and start adding new things or changing new things. But they do suffer from sort of like that. There's no path for evolution. But like plan evolution. The only way that you can change, remove, or update things is like you sort of like lockstep into it. Like you have to ask somebody else, okay, we're upgrading to version 5, or here's a new endpoint where you can use this new version of the library. And that also brings the one thing I think is good to pause here. Like it's always a good idea, and this is something that we've been doing in a lot of our projects, to have two kinds of models. One model is your internal representation, meaning like how you need the model, your object-oriented programming model that you need for your application to work. And then another model, which is your essentially your data model or your data transfer model, where that's where, for example, I'll put my JaxB generated content, or where because and the reason for this is because what happens is that you're trying to isolate your internal model changes from having it being influenced by somebody externally saying,
you don't want to break the contract, because now you have dependencies on your change going out if you change that outward facing contract, whereas your internal representation, as long as there's no external interface that's impacted, you don't have to coordinate. I mean, many large enterprise projects are based around the concept of, if I have to coordinate with you, it's going to take twice as long, because now we have to coordinate our deployments. We have to figure out, when are you going? When am I going? It makes things complicated. Pain. So, I think it's really gets back to contract management. Removals, name changes I always classify those as destructive changes, which you want to avoid, on a compatible contract. If you're going to do that stuff, you better version it. Additions are often something you can get away with. So if you're adding a field or something like that, you've seen that a lot of these parsers have it where, okay, you added a field. Well, we're just going to ignore it. So you don't actually break the contract with somebody else. All good API design.
And that is like one of the things, like one of the issues that I run into, like on one of my models, was that the external model, something, and this is something that you tend to do. For example, right now our customer has one address, but there could be a shipping and a billing address, or it could be a collection of addresses or a collection of phones. And suddenly that's a change, like, oh yeah, that makes sense. But if you happen to have used your generated contracts or your Json contracts for that, for your internal model, then the moment that you change your internal model, then you have to produce a new version of the contract for everybody to upgrade in lockstep. Whereas if you have that isolated in a different place, you can have a path forward where you can say, look, my internal contract supports multiple dates or multiple, let's say multiple addresses, but for your contract, we're going to send only the primary address because you can only accept one. And that's sort of like how you can survive these type of changes. And that's why you always want to isolate your internal model representation from your data endpoints where you're transferring out. The other things is like XML generated code, like from the JaxB is, you cannot depend, like you cannot do, for example, inheritance. You cannot just take that object and extend it.
Yeah.
Or you cannot change the hierarchy on it. This is generated code that will be regenerated every time you run your application. So you cannot make it yours, quote unquote. So that's why always try to keep your internal model separate from your external model. I know the thing that happens is that people are like, but I have to copy all these little things all over the place. You know what? It takes 2 days, but it's going to save you probably like 2 weeks of development because of the like somebody decides to add a new field or somebody decides to make a single field list. So it's worth the time. Like, I know it's one of those threat works, you know, like if you got an intern, that's his job. We all did it. We all started somewhere. Heck, I'm still doing it. Like last week I did one. So it's like, and it's fine because I know it buys me peace of mind. So definitely do it. All right. Should we go to the other ones then?
I almost feel like we have an hour of content. I feel we could break.
Yeah. Let's
Part 2 is coming next month or next week.
To be continued.
Yes.
No, because this is the fun part. Like now we're getting into the more modern serialization, deserialization frameworks that are gonna be interesting. Like, you know, like definitely XML. If you know, you probably if you're, you know, something to consider. In a very narrow band right now, but you're probably dealing with it. If you're dealing with it, you're probably dealing with it because somebody is bringing it in. But you know, JSON is definitely something that is way more modern, or at least not necessarily, definitely more still adopted a lot out there on the ecosystem, especially because of JavaScript's influence on it, and something that, you know, like if you're starting from somewhere, you know, JSON has, you know, many good sort of like arguments for it, right? But the ones that we're going to cover next are the ones that are essentially trying to address a little bit of the drawbacks that we were seeing on these two, you know, especially on performance and on contract evolution. So these are things that have been marinated a lot in Google and Facebook, and now they essentially are gifts from them to us. And again, this is essentially a little bit of a teaser for what's going to come. But yeah, and then we're going to see also like maybe what we do is I'll add some performance things in there for the next episode. See how they all compare. Yep. So
no, sounds great. Yeah, no. So we'll call it for now, but more to come on serializations to be continued. So
all right.
Hopefully you got a lot out of these two. And again, these are two very popular formats. This is the human readable segment of the show. We'll be getting back to the machine world next time.
Yes, let's become faster. All right. So that's it. You know, hope you had a good time. This is you know, Freddie signing off.
This is Bob Paulin signing off. I hope you enjoy and check us out on YouTube. You can see, you know, our ugly mugs.
Definitely. So yes. Don't forget that you can actually go to javapophouse.com, and there's in the RSS feed button, there's, you know, you can subscribe to either our regular audio feed or our video feed. You can go to our website, or you can subscribe to our YouTube channel. So you know, it's always fun, and you know, don't forget, if you haven't been part of Java of Heap, our Pundits podcast, or Breaking Into Open Source, which is our open source podcast, or Stack, which is our full stack podcast, where they talk a lot more about JavaScript than what we do here. So yeah, please subscribe to everything. Rate us in iTunes or Google Podcasts if you can, and buy us a beer. Bob already has it on his order already. Like $5 beer is a good beer too. So all right, thank you everyone. Happy programming. All right.
I will